Question number 6.270. The kinetic energy of a proton P is equals to 1.0 MeV. Striking a lithium target induce a nuclear reaction. Okay. And nuclear reaction is P plus Li7 is changing into 2He4. Means 2 alpha particles are generated. Okay. Find the kinetic energy of each alpha particle. So we have to calculate kinetic energy of each alpha particle. Okay. And the angle of their divergence provided their motion direction are symmetrical with respect to incoming proton. Okay. So it means some kind of reaction is taking place. Suppose there is a lithium nucleus, a proton is coming towards it. Okay, when it strikes, it breaks it into 2 alpha particles and they are moving symmetrically in 2 different directions. Suppose they are making total angle theta, which we want to calculate, and it is given that they are moving symmetrically with the direction of proton. So this angle will be theta by 2. Okay. So here we have to calculate first energy of these 2 particles, okay, and second angle between them, right? So let's see how we can proceed from there. First, we can calculate energy of this reaction, right? That how much energy is generated in this reaction. So we can calculate energy of reaction. Let's take it is Q. Okay, it must be equals to energy difference in this reaction from left side to right side, right? So we can write energy in Li7, okay, and this energy must be calculated in terms of mass defect because we don't have much information. So we can calculate first mass defect. So this is delta Li plus delta P, which is equivalent to hydrogen, minus 2 times delta He into C square. We are simply using energy is equals to mass defect into C square. Alright. So for lithium, it is this mass defect is 0.1601 in atomic mass unit, plus for proton it is 0.00783 in atomic mass unit, and for this helium it is 0.00502 into C square, right? So it will convert this atomic mass unit into C square into MeV. So we must be aware that 1 AMU is equals to 931 MeV. Okay, these are well-known standard values. So from here we can calculate energy of this reaction is 17.35 MeV. This is second information that we can extract from this reaction. Now coming to this picture. As when proton strikes to this Li nucleus, it is generating 2 alpha particles which are moving symmetrically. Okay, it means if they are moving symmetrically to this line, then momentum of this particle pH1, it must be equals to momentum of second particle. Okay, and here we can bring one more relation that momentum is equals to energy in terms of energy. Energy is equals to half mv square, right? So from here we can write that energy is equals to 1 over 2 into m into momentum square. So momentum can be represented for any particle as under root 2 into mass into energy. Okay. So we are going to utilize this reaction. So first of all, we can apply conservation of momentum. along x-axis. Here I am writing x means this line. Okay, or you may write along the motion of proton, right? So it means this nucleus is stationary, right? But the momentum before collision would be momentum of proton plus 0. So I am writing momentum of proton plus 0 is equals to momentum of 2 alpha particle. Okay, but along this direction. So if we'll take component along this direction, it will be ph cos theta by 2. So we can write 2 ph cos theta by 2. Okay. Now we can express these terms in form of energy. Okay. So this pH can be replaced by 2 under root 2 mass of helium. Okay. H stands for helium, which is representing alpha. Okay. So mass of helium into energy of helium. It is not known yet, into cos theta by 2 in terms of this momentum. Okay, this is our first equation. Okay, or we can calculate value of pH in terms of P. Okay, then we'll finalize this equation. We can square on both the sides, right? So from here we'll get P square is equals to 8 mH into TH into cos square theta by 2, right? So from here we may write TH, energy of helium, which expression we want to calculate, that PP square upon 8 mH, right, into sec square theta by 2. This is one equation we have got from conservation of momentum. Okay. Now we can also apply conservation of energy. Energy before the reaction is equals to energy after the energy before the collision is equals to energy after the collision. Okay, so we can apply conservation of energy, right? So for conservation of energy, we can say the energy of proton plus energy of reaction, because this process is taking place before the collision, is equals to twice of the energy of alpha particle. Okay. Now we can replace this value of pH in this expression here. So we may get this as 2 times PP square upon 8 mH into sec square theta by 2, right? Now see, interestingly here we have information about PP. It is already given. We already calculated Q, right? And PP can be calculated from there, right? So let me write here. Okay. Let me rearrange this equation here. Let's sec, or we may write cos square theta by 2. I am taking this term on left side, which is equals to 2 P square upon, or we can eliminate this term, into 4 mH, right, into 1 upon PP plus Q. Okay, we are just exchanging these terms. Okay, so from here we have got value of cos square theta, right? Now see, this PP square can be represented in terms of energy of proton using this relation. Okay, from this relation we can say that momentum of proton square can be replaced as 2 mass of proton into TP, right? So we can write here. So from there we will get cos square theta by 2 is equals to 2 mass of proton upon 4 mass of alpha particle into Tp over Tp plus Q, right? Now see, from here we can say that cos theta by 2 is equals to under root MP over 2MH into TP over TP plus Q. Now this equation is pretty simple. MP is known, here we already used this value for proton. MH is known, we already used this value. TP is given, okay, and Q is already calculated. So we will substitute and solve for angle theta. Then from this calculation we'll get theta is equals to, it is just simple matter of calculation, that 170.13 degrees. Okay, you just need to substitute values here and perform calculation taking cos inverse. So we'll get this value of theta, and here we already calculated a relation for pH. Okay, PP is known. Okay, PP can be replaced from this expression. MH is known. Theta is now known. If we'll substitute in this expression, then we'll get pH is equals to 9.18 MeV.